Hey there. There are a lot of parameters available when working with LLMs, like temperature and seed and num context and more. But do you know how to use them all and what they all mean? And although I tend to focus on Ollama, the contents of this video apply just as much for Ollama as any other tool, except for the parts where I talk about the actual implementation. You can find a list of the parameters in the Ollama documentation. Just go to the model file docs and then parameters. The first three talk about Mirostat sampling, which is a strange place to start since it's probably not the most common one that you'll use. So instead, let's start our list with what are probably the most common ones. I think the first one on our list should be temperature. The way models work is that they guess the first word of the answer and then try to figure out what is the most likely next word of the answer. And they just keep repeating that over and over and over again. When coming up with the most likely next word, or actually token, it creates a list of words or tokens that could potentially go into that next box. And they all have a probability assigned to them that shows how probable is this option as that next token. But the model doesn't actually store probabilities. It actually works with what are called logistic units or logits. Logits are unscaled when they are first generated, but they tend to be, especially with LLaMA CPP, which Ollama uses, they tend to be between -10 and 10. These logits are converted with a softmax function to a series of numbers between 0 and 1. And if you add up all the numbers, they add up to 1. So essentially, they become probabilities. Temperature helps scale the logits before they become probabilities. Lower temperatures will spread the logits out, making the smaller numbers smaller still, and the larger numbers even larger. This means that what was the most probable before has become even more probable now. But a temperature greater than 1 reduces the difference between the logits, resulting in probabilities being closer together. So tokens that had a lower probability before now have a higher chance of being chosen than they did before. The result of this is that it feels like the model becomes a little bit more creative in the way it answers a question. Now next in our list is num_CTX. This sets the context size for the model. When you look around at different models or when you see the announcement for a brand new model, you might get excited when it says a context size of 128k parameters or 8k parameters or a million parameters. But then you start to have a long conversation with, let's say LLaMA 3.1 and wonder why it's forgetting information that was actually pretty recent. In Ollama, every model starts out with a 2k context size. That means 2048 tokens are in its context and anything older may get forgotten. The reason Ollama does this is that supporting more tokens in that context requires more memory, and 128k parameters is going to require a lot of memory. From what we've seen in the Ollama Discord, a lot of people are starting out with GPUs with only 8 gigabytes of memory, and some are even smaller than that. And so that means it just can't possibly support a 128 token context, or even 8k tokens. For that reason, all Ollama models start out with a default context of 2k or 2048 tokens. So if you're excited to use LLaMA 3.1 for its 128k context size, grab LLaMA 3.1 and then create a new model file that looks like this, with a from line pointed to LLaMA 3.1 and a single parameter of num_CTX with a value of 131072. That's 128k. Then run Ollama create myBiggerLlama 3.1, or whatever you want to call it, then -F and point to the model file. This will create a brand new model that has a max context size of 128k tokens. Now you can run Ollama run myBiggerLlama 3.1 and you'll be in your new model. But let's say you're playing around with a new model and can't find the max supported size for the context. The easiest way to figure this out is to run Ollama show LLaMA 3.1. Near the top, we see the context length, which is the max supported length of the model. The fact that we don't see a parameter of num_CTX defined tells us that it is set to use the Ollama default of 2048 tokens. Yeah, that can be a little confusing. But let's say you want to use Orca 2 with a context length of 10,000 tokens. If you tell it to summarize something that is much longer than that, you'll probably not get anything useful, because the model doesn't know how to handle it. So what do you think of this video so far? Click the like if you find it interesting, and be sure to subscribe to see more videos like this in the future. I post another video on my free Ollama course every Tuesday, and a more in-depth video like this one every Thursday. Subscribing means you won't miss out on any future videos. Now, let's move on to the next thing in the list, stop words and phrases. Sometimes you'll ask a model to generate something and you see it starts to repeat itself, often using one strange word or symbol at the beginning of each repeat. So you can tell the model to stop outputting text when it sees that symbol. All the rest of the parameters only accept a single value, but stop allows for multiple stop words to be used. There are two other parameters that deal with repeats: repeat penalty and repeat last n. We talked before about how a list of potential tokens is generated along with their probabilities that they are the most likely next token. Penalty will adjust that probability if the token or word or phrase has been used recently. If the logit for the token is negative, then the logit will be multiplied by the penalty. If the logit is positive, then it will be divided by the penalty. The penalty is usually greater than 1, resulting in that token being used less, but it is also possible to set it below 1, meaning the token will be used more often. At this point, you're probably wondering how large the window is for finding repeats. Well, that's what repeat last n is for. This defines the window. The default is 64, meaning it looks at the last 64 tokens, but you can set it to be a larger or smaller window. If you set it to 0, it disables the window. And if you set it to -1, then the window is the full context of the model. Top K determines the length of the list of tokens to be generated for a potential next token. This defaults to 40, but it can be anything you like. This is pretty simple, saying that only the most likely 40 will be in the list. Top P is a little more complicated. When you add up all the probabilities in the list, you should end up with 1. But when using top P, it'll create the list of all the tokens that will add up to top P. So a top P of 0.95 will exclude all the tokens that, when you add up the probabilities, will sum to 0.05. Min P is an alternative to using top P. This looks at the source logits. It takes the value of the largest logit in the list, then figures out the value of min P % of that large value. All next tokens must have a logit value greater than that minimum value. So if the largest logit is 8 and min P is 0.25, then all logits must be greater than 2 to be considered, since 25% of 8 is 2. Okay, tail-free sampling, or TFS_Z. If you create a chart of all the probabilities, you'll see it slowly approaching 0. Tail-free sampling cuts off that tail at some point. As the number approaches 0, more of the tail will get cut off. If using this, you want to start really close to 1 and gradually come down. A value of 1 means that none of that tail is cut off. 0.99 to 0.95 is a good starting range. The docs for this one I think are wrong, and I have an issue submitted to fix it. Next one on our list is seed. One of the strengths of large language models is that they generate text much like the way that we humans generate text. They have a word, and then they think of the next word, and they think of the next word, and they think of the next, and they spit out words that make the most sense for being the next word. And this means that at the beginning of the sentence, they don't really know how the sentence is going to end. And because they're dealing with probabilities, there's a decent chance that when you ask the same question twice, the answer isn't always going to be the same. This really is one of the benefits of working with large language models. But sometimes it's not a benefit. Sometimes you want the model to answer the same way every single time. Maybe in those cases, large language models aren't really the right tool to use. But if you want to use an LLM and you want the answer to be the same every single time, then you need to set the seed for the random number generator. So large language models use random number generators to help figure out that next token. And setting the seed means that it's going to make the random number generator predictable. A sequence of numbers generated one time is going to be the same sequence of numbers every other time, if that seed is consistent. One situation where it makes sense to use this is with testing, and you want to ensure the model answers the same in your test cases. Now let's cover the Mirostat parameters. These are used by a different method of coming up with the list of next possible tokens. With Mirostat, there are essentially 3 modes to choose from. The first, if you don't set Mirostat, then top P, top K, TFS, and the rest of the parameters are used. But then you can set Mirostat to 1 or 2 to use the Mirostat tau and eta parameters to result in more or less proportional probabilities. When working with Mirostat, you often see the terms perplexity and surprise come up. They are related but different. Perplexity is a statistical measure derived from the probability of the next word appearing in a sequence. A lower perplexity indicates the model assigns higher probabilities to more correct words in a sequence. Higher perplexity indicates that the model assigns higher probabilities to less correct words. Surprise is a human emotion used as a metaphor to help understand this. A model with a higher perplexity is said to be more surprised by the output of the model, which I think is a really strange way of talking about it. It feels like the folks who came up with it don't really interact with other humans much, but that may or may not be true. But Mirostat tau controls the balance between coherence and diversity of the output. Tau sets the desired level of perplexity in the generated text. A higher value of tau will result in more diverse outputs. It usually has a range of 3 to 5 and defaults to 5. Mirostat eta is the learning rate used. A higher rate means that the model will react and adapt faster than a slower rate. This means that if the model chooses a less probable token and eta is high, the model will continue to stick with the newer style of text. A low eta is more stable and less likely to overreact to temporary changes. The final parameter we're going to cover is num_predict. This is the maximum number of tokens to predict when generating text. If you set this to -1, it'll just keep generating until it's done, and -2 will fill the context. This doesn't mean that it will always consume the entire amount, but rather that's the point where it will get cut off. Now earlier I showed how you can configure these parameters in the model file. Some of the parameters can also be configured in the default UI by entering /set parameter and then the parameter name and value. But not all parameters can be set that way. For instance, setting num_ctx that way doesn't always work. Basically, the ones that make sense to be able to change mid-conversation can be set at the command line. And that's pretty much all the parameters that folks tend to use. There are a few others that aren't documented yet in Ollama, but they are so rarely used, it doesn't usually make sense to even cover them. What do you think? Do you use any of these parameters when you use large language models? Let me know in the comments below. Thanks so much for watching. Goodbye.